Next, we move to assigning the properties to all the nodes. We start with the reservoirs. Reservoir AA only requires the total head, which is just the elevation of the reservoir, and it is given to us as 100. And you can also see here that all the properties that are marked with an asterisk are the mandatory properties. Then we move to junction J1. We need the elevation of the junction, and that is given to us as 90 feet. And we can also add a demand, which is 0. And I'll add something called demand pattern, which we'll use later on. I'll give it as number 1. Next, we move to J2. The elevation of J2 is given as 110. The demand is given as 1. And I'll also assign the demand pattern 1 to it. We also have this temporary node AA1. Since this is not shown in the network, what we'll do is we'll assign the same properties as junction J1 to it. Elevation for J1 was 90, the demand was 0, and demand pattern I'll keep it to 1. We do the same thing for all the other nodes except node 12, because for node 12 we want the demand to remain constant throughout the day, while for all the other nodes the demands change throughout the day. So if we assign properties to node 12, elevation of it is 112, the demand is 0.5, but the demand pattern for this one is different compared to all the other nodes. So we'll assign a new pattern to this one. We'll call it 2. So now I can proceed to assigning the properties to the remaining nodes. Now we proceed to the tanks. We are also given the data for the tanks. So for tank B, again, the mandatory requirements are elevation, initial level, minimum level, max level, and the diameter of the tank. The elevation is where the tank starts in the bottom level of the tank, and it is given to us as 240 feet. And the initial level of the tank is given to us as 30 feet. The minimum level is whatever the minimum amount of water that it can hold that is allowed, and again it is given to us as 0. And the maximum that we want to allow in the tank is again 30, because initially the tanks are full. Then the diameter of the tank is given to us as 60 feet. So this is the data that we want to provide for the tank. We do the same exercise for tank D. The elevation of tank D is 240 feet, and the initial level is 30 feet. Minimum is 0, and the max again is 30. The diameter is 60. So for tank E, let us try to model this one as a variable storage tank. Originally these tanks are cylindrical tanks, but what if these have like some weird dimensions? So what we can do in that case is, on this browser window, you go to curves and click on add. So here let us change the curve ID to tank E just for convenience sake, and the curve type is a volume curve. What this means is that for different height values of the tank, what the volume is. So this kind of curve provides us a flexibility in modeling any kind of tank. So a few things to note: we have to start from 0. So when the height is 0, the volume should be 0. And we know that it's a fixed diameter tank, so we know when the height is 6, the diameter is 60 feet. Because it is a cylindrical tank, so the volume should be 16,964.60. And when the height is 12, the volume is 33,929.2, and so on. Since the maximum height of the tank is 30 feet, so we have to add the numbers up to 30 feet. And this is what we get after we add all the numbers, and we click OK. So we have added this curve. Now we go to this tank E, double click. We still need to add bottom elevations, the other numbers, the initial level to be 30, the minimum level is 0, the maximum level is 30, the diameter is 60, and now we add the volume curve. So the volume curve in this case is this tank E curve. So remember that these inputs, these have to match exactly the names that are provided here. So the IDs have to match. So now we are done with the tanks. Next we move to the pumps. For pump 1, again there's no specific information that we have to provide as of now. So for pump 1, we have to have a pump curve, and for that again we go to the curves, we add a new curve, and let us call it curve ID1 because it is for pump 1. It is a pump curve, and we are given the pump curve numbers. So when the flow is 0, the head equals 270. When the flow is 8, the head is 240, and when the flow is 10, the head is 195. And I click OK. Go to pump 1 and add this curve to the pump curve property. Since the curve was named 1, so I added this, and we can keep rest everything as the default value. And similarly, I can add a curve for pump 7 and pump 25. And in this question, we are also given that initially pump 25 is closed. So we can set the initial status for it to be closed. And all the remaining pumps are open, and the default option is open. We have defined the properties for the nodes, the tanks, the reservoirs, the pumps, and now we can assign the properties to each pipe. So there is no direct way to assign properties to each pipe. We have to manually select the pipe and assign the pipe length and the diameter and the roughness for that pipe. So we start with pipe 1. The length is 2000 feet, the diameter given to us is 20, and the roughness is 98, and we are not given any minor loss coefficient of that. Next we move to pipe 2. Now we have provided the properties to all the pipes in the system.